Okay, so here we are on quiz number 5. And it's first one on Unit 3, covering homeworks 1 through 3 on Unit 3. So first off, use Gauss's approach to find adding up the numbers 1 through 1002. So 1, 2, 3, 4, all the way to 1002. So remember what Gauss's approach was. You write the list backwards down below. So I'll write 1002, 1001, etc., all the way down to 1. And then you just add them straight up and down. Just add them up. So like these two add up, 1003, plus these two add up. Notice it's the same total, 1003, etc., all the way down to here. They're all going to be 1003. So if you add up the list forwards and backwards, straight up and down, every total will be 1003. And how many 1003s do we have? Well, we have one for each column. And how many columns are there? 1002 columns. So there's 1002 1003s. Does that make sense? Right? Here's the first 1003, the second 1003, etc., all the way to the 1002, 1002nd, 1003. Okay, but that's the list twice, isn't it? Because that's the list once forward, once backward, so you got to divide that by 2 to get the real answer. And so then just use your calculator, and I'm going to do my calculator. I'm getting, this is equal to, it's a big number, 502,503. All right, let's try, so that's the list forwards and backwards. And then you just add them vertically. Let's try part B. I'll go to a fresh screen there. So part B, we're going 1 plus 3 plus 5 plus 7, all the way to 999. We're just doing the odd numbers. So then reverse the list. 999. This would be 997, 995, 993, all the way to 1. Right? So you just write the list forwards and backwards. So now you've got the list twice. So whatever total you get, you're going to have to divide by 2 in the end because we got the list forward and backwards. So now add them straight up and down. What's 1 plus 999? Well, it's 1,000. Plus, and then what's 3 plus 997? Well, it's 1,000 again. Plus, and what's 5 plus 995? Well, it's 1,000 again. And what's 7 plus 993? 1,000 again. And this right here, 1,000 again. So it's a whole bunch of 1,000s. Now the question is, how many thousands do we have there? Well, we have one for each spot. One for the 1 spot, the 3 spot, the 5 spot, the 7 spot, all the way to the 999 spot. Well, how many is that? It goes to 999. It's about half of that, right? Is it about 500? Is it 499? Is it 501? It's around 500. How do we know exactly what it is? We better be a little bit careful here. Here's a good way to do it. If you're looking at a bunch of odd numbers, like we are, we're looking at 1, 3, 5, 7, 9, blah, 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 all the way to 999, and we're wondering how many numbers are there? Well, try a little pattern. What if you just had 1, 3, and 5? That is certainly 3 numbers. So what could you do to take that pattern? You could take the last number, and you could just go up by 1, 6, and then divide by 2, and you would get the total. Let's try it for 7. If you want 1, 3, 5, 7, that's the last number. If you just go up by 1, 8, divide by 2, 4 numbers, that's right. There's 4 numbers there. So you just go one more than the last number and divide by 2, and you'll get the total number of numbers. So you take the 999, go one more than the last number, 1,000, divide by 2, that's 500. There must be 500 numbers there. Does that make sense? There must be 500 numbers in our list. So that means we have 1,500 times, right? 1,000, 1,000, 1,000, 1,000, 1,000. How many of those? There's 500 of them. Because you just, if it's odd, say we're going odd, you just take the last number, go up one more, and divide by 2. So, but then divide by 2, and again, because that's the list twice. So we divided by 2 here just to find out how many numbers are in the list, because there's just odd numbers. There's not every number. And then we had 500 1,000s, and then you got to divide that all by 2, because that's the list forwards and backwards. So then if you do that, you get 250,000. There it is. There's our answer to part B. All right, let's go on to number 2. So number 2, Kathy stood on the middle rung of a ladder. She went up 4, down 3, up 8, up remaining 4 to the top. All right, so really we have to draw this out. I'm going to go over here with someplace I can draw on. Yeah, how about this? Okay, so I'm going to use this. So what did Kathy do on number 2? She started on the middle. So here's number 2 with Kathy. She started, I'll put the middle like right there. She started on the middle rung of the ladder. And she went up 4. So she went up 1, 2, 3, 4. Up 4. And then she went down 3. So she's right here and went up 1, 2, 3, 4. Now she's right here and went 1, 2, 3. That's where she's at now. And then she went up 8. Let me use a different color here. Up 8. So from here, she's on at this part. She went up 1, 2, 3, 4, 5, 6, 7, 8. That's up 8. And then up 4 more to the top. So up 4 more to the top. 1, 2, 3, 4. Right there must be the top. And remember, this was the middle from the beginning. So, how many rungs are there above the middle? 1, 2, every one of these lines, right? This line, these are all rungs on the ladder. Here's the ladder going up to the top. These are all rungs on the ladder. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rungs above the ladder. This is the middle rung, and so there must be 13 below because that's why it's the middle. So we have 13, we have the 1 in the middle, and we have 13, 27 rungs on the ladder. Does that make sense? 13 above the middle, 13 below the middle because it's the middle, and then the 1 in the middle rung itself. 27 rungs. All right, so number 3, find the 100th and the nth term for each of the following sequences. Okay, so they want us to find the nth term. So notice this sequence is adding the same number every time, isn't it? Just adding 5 every time. So we had a formula from class. This is called an arithmetic sequence, just adding the same number every time. And our formula from class was the nth term equals the first term plus n minus 1 times the jump amount. That was the formula we discovered. So, therefore, the nth term will equal the first term, so that's the 1, plus n minus 1 times the jump. The jump is the 5. It's going up by 5 every time. It's jumping by 5 every time. So then you simplify that formula. The nth term is 1 plus you distribute that 5. 5n minus 5, which is 5n minus 4, right? Because 1 and minus 5 make the minus 4 at the back. They together make that minus 4. So there's the nth term formula. 5n minus 4. And then they ask us for the 100th term as well. So the 100th term would be 5 times 100 minus 4. You just plug in for n 100. It's going to be 500 minus 4. What's that? 496. So there we go. So 496 is the 100th term. And what was the formula? 5n minus 4 is the formula for the nth term. Let's go on to part B. So 50, 90, 130. So part B. So what's going on there? What's happening? It's again going up by the same amount every time. This one's adding 40 every time. So the nth term is the first term plus n minus 1 times the jump. So the nth term is the first term, 50. So I'll go right there, 50. Plus n minus 1 times the jump. What's the jump? That's the 40. It's the jump going. It's the amount that's going up every time. So now just distribute that 40. Simplify. 50 plus, and that 40 distributes 40n minus 40, which is 40n plus 10, isn't it? Because 50 minus 40 together make the 10. So there's the formula for the nth term, 40n plus 10. That goes right here, 40n plus 10. The nth term, 40n plus 10. And now, last thing is they want me to find the 100th term. So that means plug in 100. And so that's 4,000 plus 10. That's 4,010. 4,010. Let me write this a little better. All right. Let's go on to part C. Okay, so here's part C. Now on this one, what's it doing every time? See, it adds 1, adds 2. Oh, so it's not adding the same number each time. It's not an arithmetic sequence. So we cannot use that formula. Nth term is first term plus n minus 1 times the jump. We can't use that because this one is it's not adding the same number every time. So we can't do that, so we got to scratch that plan. What are we going to do then? Let's go back. 1, 2, 4, dot, dot, dot. So we have to come up with a new game plan. We got to kind of look for the pattern ourselves. Well, what's going on? 4 is 2 times 2. And this is just a single 2. So let's add some more terms here. We know what would come next, right? The next one, it looks like it's just doubling every time, right? 1 times 2 is 2 times 2 is 4. So next would be 8, 16, 32, etc. I'm doing that to look for the pattern. Now, what does 8 come from? Well, it's 3 2's multiplied. And where does 16 come from? 4 2's multiplied, etc. So, in other words, we're just multiplying by another 2 every time. So this is 2 to the first power. This is 2 to the second. This is 2 to the third. This is 2 to the... Well, what's the 1? 2 to the 0. Remember that pattern? Remember the formula that anything to the 0 power is just 1? So there's the formula. There's what's happening, right? Because that's 4 2's, 3 2's, 2 2's, 1 2, no 2's at all. It's just the number 1. So there's the pattern. Now, we got to be a little careful, though. This is the n equals first term. This is the second term, third term, fourth term, fifth term, etc. So notice that the fifth term has a 4 there, 2 to the fourth power. The fourth term is 2 to the third power. The third term is 2 to the second power. etc. So, right, second term is 2 to the first, and the first term is 2 to the 0. The power is always 1 lower than the term number. So therefore, it's equal to 2 to the n minus 1, isn't it? The power is always 1 lower than the n term number. So there's the formula for the nth term. And now they want us to find the 100th term. Plug in 100 right there for n. And that'll be 2 to the 99. So 2 to the 99, 2 to the n minus 1. There it is. Now, number 4, we had to find our own pattern because it was not adding the same number every time. It was not an arithmetic sequence. We could not use the formula. We had to find our own pattern in the powers on the 2's, and it was always 1 lower than the term number. Okay, so now part D, 7 to the 3rd, 7 to the 5th. Okay. What it does. 7 to the 7th. I guess it's one more, huh? Okay, so what's going on there? Well, if we just get rid of the 7 and I'll put a 1 in there because 7 alone is 7 to the first power. If we just look at the powers, we see 1. So if we just look at the powers, only the powers. 1, 3, 5, 7. Is that adding the same number every time? Yeah, add 2, add 2, add 2. So that is adding the same number each time. So we can use the formula. That means it's arithmetic. It's what we call an arithmetic sequence. So we can use the formula. The nth term is the first term plus n minus 1 times the jump amount. So we'll use the formula. And so let's try it. So the nth term will be the first term. What's the first term? 1 plus n minus 1 times. What's the jump? That's the 2. Alright, so the nth term is distribute 2n minus 2. And so the nth term is 2n minus 1, right? 1 minus 2 makes minus 1, so 2n minus 1. So really then, that's just the powers. Excuse me. Losing my voice from a cold. That's just the powers there. So the actual nth term is 7 to the 2n minus 1, right? The 2n minus 1 is just the power. It's just what's happening up here in the power zone. We can't forget about the 7 that is the base for all of them. So that's the nth term. And then we can find the 100th term. That'll be, just plug in 100 right there. That'll be 7 to the 199. So 7 to the 199 and 7 to the 2n minus 1. All right. Finally, part E. It's a long one here. So part E is 156 plus 6 times 3 to the 30th. 156 plus 7 times 3 to the 30th. So 4E plus 6 times 3 to the 30th, comma, 156 plus 7 times 3 to the 30th, 156 plus 8 times 3 to the 30th, Is that true? Yeah, okay. Well, if you look what's happening there, I bet you can see it. The 156 and the 3 to the 30th, they're just always there. 156 in the front, 3 to the 30th in the back. 156 in the front, 3 to the 30th, 3 to the 30th in the back. The only thing that's changing from term to term here is the number right there in the middle. 6, 7, 8. So let's just take those out. 6, 7, 8, That is adding the same number every time. It's just going plus 1. So it's adding the same number each time, so we can use the formula. Nth term is the first term plus n minus 1 times the jump. So the nth term is going to be the first term, which is 6, plus n minus 1 times the jump. What's the jump? What's it going up by every time? 1. And then simplify. Distribute this. And so that's n plus 5, isn't it? Right? 6 minus 1 makes 5. So n plus 5. So the actual nth term then, put the 156 back in the front. I do that. We get the 156 in the front. And we get the 3 to the 30th in the back. And then n plus 5 is what goes right there in the middle. So this whole pattern, 6, 7, 8, was the middle number, which is n plus 5. That's what goes in the middle, with a 156 in the front and a 3 to the 30th at the back. So this will be 156 plus n plus 5 times 3 to the 30th. Okay, and now let's plug in and find the 100th term. So plug 100 in right there. Get 156 plus 100 plus 5 times 3 to the 30th. That's 156 plus 105 times 3 to the 30th. There it is. 156 plus 105 times 3 to the 30th. Okay, on we go to number 4. Find the ones digit for 3 to the 50th. Let me write it right here. Ones digit 3 to the 50th. Okay. So basically, there's no way to do this without a pattern. You really have to just go for the pattern. So let's find out what 3 to the 1 is. That's just 3. What's 3 to the 2? That's just 9, right? 3 squared. What's 3 to the third power? 3 times 3 times 3 is 27. What's 3 to the fourth power? If you use your calculator, 3 to the fourth power, just multiply by another 3 every time is 81. 3 to the 5th power is 243. Let's just do a few of these. 3 to the 6th is 729. 3 to the 7th, let's see here, I'm using my calculator, is 2187. 3 to the 8th, just keep multiplying by another 3 every time. 6561. 3 to the 9th is 19,683. Now, what are we supposed to be looking at? Just the one, I forgot the S there, just the ones digit. So just the 3, the 9, the 7, the 1. 3, the 9, the 7, the 1. See that pattern? 3, and on it goes. See how it just keeps repeating? 3, 9, 7, 1. 3, 9, 7, 1. 3, 9, 7, 1. It's going to keep going forever. 3, 9, 7, 1 in a cycle of 4 digits. And all we care about is the last one on the 50th, way down here at 3 to the 50th. What will be the ones digit? Well, it's just repeating this cycle. So it's repeating a cycle of 4. So basically we're asking how many whole groups, how many groups of 4 in 50, right? Because we're going out to 3 to the 50th. So how many whole groups of 4 will we have? Well, we can figure that out by dividing. 4 goes into 50. 1 time 1, bring down the 0. 4 goes into 10. 2 times 8. There's the remainder of 2. So there's 12 groups of 4 in 50. Because 12 times 4 is 48, right? So there's 12 groups of 4. So on your way out to 3 to the 50th, you'll go through 12 groups of 4. So a whole group of 4, a whole group of 4, a whole group of 4, etc., etc. 12 groups of 4. 12 groups of 4 is 48. Then 2 more remain. That's our remainder. 2 more remain to get to the 50th, right? 12 groups of 4, 48. Then 2 more remain. Well, so you'll go through the think about what the digits will do. 3, 9, 7, 1. New group of 4. 3, 9, 7, 1. New group of 4. 3, 9, 7, 1. New 3, 9, 7, 1. Keep going. All 12 groups of 4 will do that. And then 2 more will remain. So you'll start the last group, which is 3, 9, 7, 1. And you'll go first digit, second digit into that last group because 2 more remain. Remainder 2. And it just keeps cycling 3, 9, 7, 1. So 3, 9, 7, 1, but you'll only go 2 more into the last group after 12 full groups of 4. So that'll be 3, 9. There it is. 9 is the last digit. It's the 50th digit because it'll go 2 more. Boom, boom. 3, 9. It'll stop on 9 in the 50th term. So 9 is the ones digit. The ones digit is 9. For that crazy big number, 3 to the 50th. We can't even figure out what 3 to the 50th power is on our calculator. It won't even show us all the way down to the ones digit if you do it. It can't go all the way down to the ones digit because there's so many digits. But by the pattern, the power of logic in a pattern, we can see that the ones digit must be 9 because there's 12 full groups of 4 and it just keeps going 3, 9, 7, 1, 3, 9, 7, 1. So it'll keep doing that all the way out and then 2 more remain into the last cycle. So it'll go 3, 9 and it'll stop on a 9. There we go. Okay, so we're on number 5, looking for the pattern here. So this first one's pretty easy. You see the pattern? 7, 1, 3. 7, 1, 3. So 7, 1, 3. 7, 1, 3. So that was easy. How about the second one? 2, 3. 2, 3, 4. 2, 3, 4, 5. 2, 3, 4, 5, 6. There it is. Next one. A little more tricky here. This is adding 1. I don't know. Add 1 again, then add 2, then add 3. That's weird. Oh, it's an adding pattern. 1 plus 2. 1 plus 2 adds to be 3. And then you do it again. 2 and 3 adds to be 5. And then you do it again. 3 and 5 add to be 8. See how you just add 2 numbers and that leads you to the next number? This is actually a famous sequence. It's called the Fibonacci Sequence. And it occurs in nature a lot when we see the spiral patterns in certain flowers and the way the petals work. There's some things that fit that's very interesting and observable pattern. So just keep going. So add 5 and 8. get 13. Then you do it again. Add 8 and 13, that'd be 21. And then do it again. Add 13 and 21, get, what's that, 34. And then you can verify the last one's correct. If you add 21 and 34, you do get 55. So see, it's just adding two numbers to get the next number. All right, what's happening here? It's a strange one. Oh, it's multiplying, huh? 1 times 2 is 2. 2 times 2 is 4. 2 times 4 is 8. 4 times 8 is 32. 8 times 32, use your calculator, 256. It's right there. It's a multiplying. It's multiplying two numbers to equal the next number. And the Fibonacci is adding two numbers. All right, let's keep going here. This one is adding 3, just adding 3 every time, isn't it? So this would be 13, 16, 19, add 3, 22. That's perfect. Okay. Next one's super tricky. I'm just going to tell you the answer. You got to think about every other. So 1, 2, 5, 8, 11. Think about that, and then these guys are a different pattern. It's two patterns interspliced, mixed in with each other. So let's look for the purple pattern. What's happening in the purple numbers? 2, 5, 8, 11. It's adding 3 every time, huh? So, but it skips to here, adds 3. 14, skips to here, adds 3, 17, perfect. Skips to here, add 3, 20. Okay, now what about the red pattern? What's it doing? It's adding 2, adding 2, adding 2, adding 2, adding 2, adding 2. There we go. It's two patterns in one mixed together. They're getting a little trickier. Okay. Now this one looks like it's subtracting. What is that? 2 minus 8. Is it minus 8 again? Yeah, minus 8. Minus 8. Yeah, it's just minus 8 every time. So this would be 30. And then minus 8, this would be 22. Minus 8 would be, what's that, 14. And then minus 8 would be 6. Yeah, perfect. Just subtracting 8 every time. Okay. Now, what's this one doing? Is it going times 3, times 3, and then times 3 again? That'd be, what's that, 54? And then times 3 again, 162. And then times 3, 486. Perfect. It's going times 3 every time. So there we go. We found all those patterns. Okay, so here's number 6. 2 hot air balloons are off the ground. On the first balloon, the distance from the bottom of the basket to the top of the balloon is 15 feet. So I could draw my first balloon here. So from there to there is 15 feet. Top of the balloon, from the bottom of the basket to the top of the balloon, 15 feet. So this is number 1. Balloon number 1. Balloon number 2, the second balloon, this distance is 20. So the second balloon, the second balloon has a little bigger distance there. So this is 20 bottom to top. The top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket. Oh. So the top of balloon 1's balloon down to the, okay, so I better shift this a little bit. Okay, let me try to move balloon 1 down a little bit. So I'll move balloon 1 here. So here's balloon number 1. Doesn't really look like a balloon. The balloon's smaller than the basket, huh? Balloon number 1, and it was 15 feet top to bottom. And then they're telling me the top of balloon 1's balloon right there to the bottom of balloon 2's basket right there. So I use double-sided arrows and lines to be real clear. Is 6 feet. On 6 feet. Okay. Here, I still don't like my drawing. It's not super good. Let me try to do a little better job here. So we got balloon 2. Balloon 2. And then we got balloon 1. Oh, try a little bigger one there. Balloon 1. And it says the top of balloon 1's balloon to the bottom of balloon 2's basket is 6 feet. And then this is 15 feet, top to bottom balloon 1. And then top to bottom balloon 2 is 20 feet. Okay. Now, if the distance from the ground to the bottom of balloon 1 is 50 feet. All right, so I got to put the ground in here, I guess. So this is 50. It doesn't look like 50 on my diagram, but good enough. 50. From the ground to the bottom of balloon 1's basket is 50. How far is it from the ground up to the top of balloon 2's balloon? So from there all the way to there is what they're asking. All right, how am I going to figure that out? Well, so see how I had to keep fiddling with that picture until it fit all the words correctly. All right, well, what could we do? If we could figure out how far from there to there, right? Because it would be 20, take away 6, 14. So this is 14 and 6 to make 20 total from that level to that level, right? Okay. So now, if I want to go from the bottom to the top, starting right here, I can go to this line, that's 50, then I can go to this line, that's 15 right here, and then I can go to this line, and that's 14. And so all together, 14, 15, and 50, 79 feet. Must be the answer. 79 feet. So the picture is crucial. That'd be an impossible question to answer without a picture. The point of this word problem is to get you to use the technique of drawing a picture to solve the problem. Okay, so last one, number 7. Find the sum of these numbers. So start with 40, 41, 42, 43, dot, dot, dot. 116, 117. So how are we supposed to do this? Remember the trick? Write the list forwards and backwards down below. So 117, 116, next would be 115, 114, dot, dot, dot. All the way, the last two would be 41 and 40. So there's the list forwards and backwards, and then add them up, right? Remember, add them straight up and down. They'll always come out to be the same number. 157 right here. 157. See how it's always coming out? 157, 157, dot, dot, dot. Even right here, 157, 157. So it's a whole bunch of 157s. Again, this is the list twice. Once forwards, right? I wrote the list forward and backward. Forwards and backwards. So my answer is this is the list twice, so I need to divide by 2. But first, how many 157s are there? How many of these 157s are there? Well, there's one that starts at the 40, 41, 42, 43, all the way to 117. How many numbers from 40 to 117? Because that's what we're asking, right? How many are there from 40 to 117? Well, 1 to 39 are missing, aren't they? So 117 minus 39, I can't really do that one without a calculator. 117 minus 39, I'm getting 78. There must be 78 numbers there because it goes all the way to 117, but it's missing 1 through 39. So take away 39 numbers from 117, and you get 78 numbers. So that means there's 78 157s, aren't there? Right? Because there's 157 in each one of these spots, and there's 78 spots. So there's 78 157s. But then we got to divide by 2 because that's the list twice, once forward, once backwards. So that's what they're all going to add up to be. Let's see what we get. 61, 23. There's the sum of the list. 61, 23.